Prompt engineering averages a stunning $164,140 a year. But here's the catch. There are only 7,359 job postings for it. Python alone has 137,000 openings. The money isn't in writing better prompts. It's in mastering the vector databases that power retrieval-augmented generation, the backbone of every production AI stack in 2026, and the fastest way to break into that world? Build your first face index with sentence transformers tonight. Look at the numbers. Prompt engineering has only 7,359 postings. Microscopic next to Python's $137,000 and software engineers' $140,000. Even machine learning, the field where RAG and vector databases actually live, has 77,000 openings. The market isn't hiring prompt tweakers. It's hiring engineers who can build retrieval systems. Vector database skills are embedded across that 100K plus job market. They're the real career accelerator. If your app just fires prompts at a GPT API, you're one model update away from broken behavior, hallucinations, stale knowledge, and uncontrolled costs. The escape hatch is RAG, user query, vector search to pull relevant document chunks, context injection, then a grounded LLM response. When you own the retrieval layer, you stop being at the mercy of the API. The prompt engineer job title has vanished. In 2026, companies are hiring AI architects and agentic MLOps engineers, roles that demand you build RAG pipelines, not craft clever one-liners. AI ML engineer salaries already top out near $189,500. The career-defining move isn't getting better at prompting. It's mastering embedding, indexing, retrieval, and vector databases, your unshakable technical moat. Every RAG pipeline starts with embeddings. A sentence like "the cat sat on the mat" gets fed into a model such as all mini LM L6 V2 and turns into a list of 384 floating point numbers, a high-dimensional fingerprint. Texts with similar meanings land near each other in this mathematical space. That's the magic behind semantic search. Search by meaning, not exact keywords. But here's the part. Almost everyone gets wrong. It's not the model size that makes RAG work at scale, it's the search algorithm. HNSW, Hierarchical Navigable Small World, builds a multi-layer graph. A search starts at the top, hops between layers using long-range links, then drills into dense local connections at the bottom. Production vector databases like FACE and Qdrant rely on HNSW to retrieve relevant vectors in under a millisecond, even across millions of embeddings. That's the difference between a toy RAG demo and a system that actually ships. Your tool belt. FACE gives you low-level control and deep understanding. Sentence transformers turn text into vectors. Pinecone and Qdrant handle scaling when you need managed or self-hosted speed. Pair them and you've got a complete RAG stack, open source to cloud, and that combo on a resume makes you stand out instantly. Step 1. Turn your documents into vectors. Import sentence transformers, load the free all-mini LM L6 V2 model, and encode your text. You'll get back a 384-dimensional array, the mathematical representation of your content. This runs locally in under 5 minutes. It's the gateway to every RAG pipeline. Now create a FAS index. For learning, start with IndexFlatL2, a brute force exact search that works perfectly on small datasets. Set the dimension to 384, add your embeddings, and your knowledge base is query ready. When you need to scale, you'll swap this flat index for an IVF or HNSW index, but the core API stays the same. Run this now, and you'll have a working vector database. Finally, the retrieval to generation loop. Embed your user's question, query face, for the top 3 most relevant chunks, then inject those chunks into a prompt template. Something like context, chunks, question, query. Send that to an LLM and you've just built a working RAG pipeline. From zero code to a grounded factual answer in under half an hour. That's the skill that puts you ahead of 90% of applicants. Chunking is where most RAG pipelines fail silently. Pick the wrong size or overlap, and your retrieval returns useless fragments. Fixed size splits. Butcher context. Recursive character splitting. Specifically LangChain's recursive character. Text splitter with chunk size 500 and chunk art overlap 50. Keeps related sentences together and prevents splitting a critical definition right down the middle. For dense, multi-section documents, a semantic splitter that respects paragraph boundaries is even better. Skipping this step is the single most common beginner mistake that costs production accuracy and your reputation. Most RAG demos skip evaluation completely. They just eyeball the output and hope it looks right. Senior engineers don't. They set up an evaluation pipeline with tools like RAGAs or manual scoring and track precision EK, recalc, mean reciprocal rank, and NDCG. These numbers tell you if your retrieval is actually surfacing the right chunks. Without them, your system degrades silently over time as new documents come in or embedding models shift. The numbers on screen are from a healthy pipeline. Compare yours to these, and you'll know instantly if you're in trouble. But here's what nobody tells you about vector databases. They aren't just a better search bar, they are the memory layer for autonomous AI agents. Agents that negotiate, reason, and act rely on vector stores to recall past interactions and corporate knowledge. Without this layer, an agent is an amnesiac, unable to build on anything it hasn't just seen. The open-source CubeStellar project proved this out. By giving AI agents a vector-stored codebase context, they hit an 81% PR acceptance rate. That level of autonomy is impossible without persistent semantic memory. The role of prompt engineer has vanished. It's been absorbed by two titles hiring managers are actively chasing: AI architect and agentic MLOps engineer. These roles demand vector database proficiency because they orchestrate agents that retrieve, reason, and act. Exactly the shift documented in the CubeStellar breakthrough and real 2026 job descriptions. If you're applying for AI jobs right now, search Agentic MLOps on LinkedIn and look at the required stack. You'll see vector databases front and center. Here's what that expertise is worth. AI ML engineers who can build and scale RAG pipelines sit at the top of the pay band, pulling in $180,900 a year. Job postings that mention AI skills command a 28% salary premium, about an extra $18,000 annually. Vector databases are at the core of those high-value listings because they're the key to production-grade AI, not just demo-ready chatbots. That's a direct line from learning 5 to 6 extra figures over your career. Top-tier infrastructure engineers in 2026 merge cloud, AI, and vector databases into a single, resilient stack. Bedrock or SageMaker handles model serving. Kubernetes, especially with CubeStellar agent extensions, orchestrates the workloads. Pinecone or Qdrant provides the vector memory layer. Langsmith watches for drift and hallucination. GitOps keeps everything reproducible. If your resume only lists prompt engineering, you're showing up to a full-stack battle with a single command. This grid is what the highest-paying job descriptions actually ask for. Start building today. This is what agentic AI looks like in production. When a developer opens a pull request in the CubeStellar project, an AI agent fires, queries the vector database for similar code changes and architectural history, then formulates a review suggestion grounded in real context, not just a generic response. The result? An 81% PR acceptance rate because the agent isn't guessing. It's retrieving from high-dimensional vector spaces that store the entire project's memory. Prompting alone could never replicate that. An application that only wraps an API call is one model update away from breaking, and one pricing change away from extinction. Tacking on a RAG layer with your own vector store turns that fragile dependency into a resilient product. You control the retrieval, you fine-tune the context injection, and you own the data that makes responses accurate and unique. This is the moat that separates a commodity wrapper from a product an enterprise will actually buy, and exactly the architecture that commands top salary tiers. Prompt engineering can be picked up in a weekend, and already is. That's why it's not a career moat. But designing and scaling a vector retrieval system that handles millions of embeddings, shards across clusters, and stays accurate under load takes months of infrastructure mastery. That scarcity can't be duplicated just by upgrading a model. It makes you the person hiring managers can't afford to lose. A living moat they'll pay top dollar to breach. A flat face index works great for a 10-minute demo and falls apart at 1,000,000 documents. Real-world scale demands HNS-W for fast approximate search with low memory, then IVF with product quantization to compress embeddings, and finally sharding across multiple nodes. Interviewers test exactly this. When do you leave index flat IP behind? If your answer is never, you just failed the senior round. Mastering this progression is how you go from notebook engineer to infrastructure lead. And that's the skill set the 108.9K bracket pays for. This is the production post-mortem nobody talks about. You trained your entire vector database with one embedding model, say All-Mini-LM L6 V2. 6 months later, you upgrade to a shiny new model with higher dimensions. But guess what? The vector space is completely different. Those old embeddings are now meaningless. Your similarity search silently returns irrelevant results. Your RAG pipeline starts feeding nonsense to the LLM, and your users start wondering why the assistant has gone senile. The fix. Version your embeddings like you version your code. Store the model ID and parameters as metadata in your vector database. Tools like MLflow's model registry make this trivial. If you do switch models, re-embed every single document, period. This is the kind of footgun that costs startups their reputation and engineers their credibility. Don't be the culprit. Most RAG pipelines die in production because of 5 mundane, fixable mistakes, not because the model isn't smart enough. First, nobody watches latency. A retrieval that takes 2 seconds feels broken even if it's right. Second, the vector database becomes a single point of failure. Lose Qdrant or Pinecone, and your whole system goes dark. Third, a freshly deployed index has no cache, so the first real query crawls while users wait. Fourth, raw similarity scores alone let irrelevant chunks through, poisoning the LLM's context. And fifth, teams ignore hallucination scores entirely. The model spews confident falsehoods and nobody catches them. Fix each one with a concrete mitigation. Tracing, a backup keyword search, pre-warmed indices, a minimum cosine threshold, and a fact-checking guardrail on final answers. That's what separates a toy demo from a system your company can actually rely on. Mid-level engineers build the RAG pipeline. Senior engineers build the observability layer around it. You need to know exactly what your retrieval system is doing, how long each query takes, what the Recall 5 score looks like, whether your embedding space is drifting over time, and which chunks are actually being used. The stack is straightforward. Instrument your RAG pipeline to emit logs and metrics, feed them into a dashboard like Grafana or Langsmith, and set alerts when retrieval precision drops or query latency spikes. Track metrics like retrieval precision, user feedback signals, and embedding drift. If the distance between queries and their nearest neighbor starts growing, your index is rotting. This is the skill that gets you promoted from builder to operator, and it's exactly what AI infrastructure roles are paying top dollar for. Trying to learn RAG by staring at blog posts is a one-way ticket to tutorial purgatory. Here's a concrete 12-week plan that takes you from 0 to interview ready. Weeks 1 and 2. Get comfortable with Python and generate your first embeddings using sentence transformers. Weeks 3 and 4. Install Thais locally, index a few hundred documents, and see how nearest neighbor search actually works. Weeks 5 and 6. Graduate to a managed service like Qdrant, run it via Docker, create a collection, and insert vectors from Python. Weeks 7 and 8. Wire it all together with LangChain to build a real RAG pipeline that answers questions backed by your own documents. Weeks 9 through 12. Ship it. Switch to an HNS-W index for production speed. Tune your chunking strategy, containerize everything with Docker or Kubernetes, and evaluate with Recall. That's a 90-day path from "I've heard of vector databases" to a project worth putting on your resume. Your resume gets about 6 seconds of human attention, unless there's a number that makes them stop. Worked with Thais is a snoozer. Built a RAG pipeline with FIs, improving retrieval precision from 0.72 to 0.91 is a conversation starter. See the difference? One tells them you touched the tool, the other proves you know how to measure and improve it. Bullet 2. Optimized chunking strategy, raising NDCG from 0.60 to 0.85. Now you're talking about a skill that directly impacts answer quality. Bullet 3. Reduced average query latency by 60% on Qdrant shows you actually deployed something and made it faster. These are the bullets that get past the applicant tracking system and into the hiring manager's call list because they demonstrate impact, not just exposure. Steal them, adapt them, and put one on your resume this week. Here's the career cheat code nobody is saying out loud. If you're already a cloud engineer, you know AWS, Terraform, Docker, Kubernetes, you already have most of the foundation for the hottest hybrid role of 2026, the AI cloud engineer. The crucial missing piece? Vector databases, embedding models, chunking strategies, RAG pipeline optimization, and observability for AI workloads. Stack those on top of your existing cloud foundation, and you transform from a $130K cloud generalist into the candidate companies are scrambling to hire at $189K. You don't need a PhD. You don't need to become a data scientist. You just need to add the retrieval layer, the memory of AI, to the infrastructure you already know how to run. That's the skill delta that prints money. Let's talk numbers. The average AI ML engineer salary hovers around $170–750. Not bad. But engineers who bring vector database and RAG expertise, the ones who can build the memory layer, not just call an API, are among the top earners, commanding salaries up to $189,500. And remember, job postings that mention AI skills in general already carry a 28% premium on average. The market is screaming what it values. People who understand retrieval, not just prompt crafting. That second bar? That's not a gifted genius. That's a cloud engineer who added Face and Qdrant to their toolkit. That could be you. Here's an uncomfortable truth. Every hour you spend polishing the perfect system prompt is an hour you could have spent building a retrieval pipeline that actually scales. A great prompt can nudge a single answer, but a well-built vector index can improve thousands of answers automatically by giving the model the right data in the first place. The prompt engineer job title is already vanishing. The data backs this up. Under 8,000 job postings mention prompt engineering compared to over 130,000 for Python. The real leverage in 2026 is retrieval, embedding your documents, storing them in a vector database, and letting semantic search feed the LLM exactly what it needs. Stop chasing the magic prompt and start building the memory layer. That's where the career acceleration lives. Cognitive sovereignty sounds academic, but it's dead simple. Don't let the machine do your thinking for you. In 2026, the most dangerous skill gap isn't not knowing how to prompt. It's losing the habit of forming your own point of view before the model speaks. When you're building RAG systems, this hits especially hard. If you blindly trust the vector database's top K results, you will deploy hallucinations at scale. Instead, you need to read the retrieved chunks yourself, check whether they actually support the answer, and override the pipeline when the similarity scores are misleading. That judgment, the willingness to say, this retrieval is garbage, I'm not passing it to the LLM, is what separates the accountable AI engineer from the prompt copier. Fluency is table stakes now. The real career skill is keeping your brain in the loop. Vector databases feel intimidating until you realize you can have one running on your laptop in 5 minutes. Here's the exact sequence. Copy-paste ready. First, fire up Qdrant with a single Docker command. Docker run opia 6333 ERX63 3 Qdrant. That's it. You now have a production-grade vector database listening on localhost. Then, from Python, install the Qdrant client, create a collection with 384-dimensional vectors, matching all mini-LM L6 v2 embeddings, insert a few pre-computed vectors with metadata, and run a nearest neighbor query. The whole thing takes under 300 seconds, and suddenly vector databases go from a scary interview topic to a thing you've actually built. Try it tonight. The intimidation factor disappears the moment you see query results come back. Raw coding. Similarity gets you a demo, not a product. The hallmark of a senior AI engineer is hybrid search. Combine lexical BM25 with dense vectors so you never miss an exact serial number. Then layer on metadata filtering. Limit your search to tickets from the last 6 months or only servers in Europe to cut noise instantly. Finally, pass your top 100 candidates through a cross-encoder re-ranker like Cohere Re-Rank or Sentence Transformers MS Marco model. That second pass reorders results by real relevance, pushing your retrieval accuracy into enterprise territory. Hiring managers ask for this because it's the difference between a toy and a system that actually saves money. If you store vectors without the original URL, title, and a creation date, you've built a black box that can't be audited. The moment an interviewer asks, "How do you attribute retrieved chunks?" you have no answer. Every production system needs to show where a piece of context came from, not just that it's similar. In Qdrent, you attach a payload dict with source, URL, title, and indexed at to every point. In Pinecone, you do the same with metadata. This one habit turns a fragile prototype into a trustable, interview-ready system. Skip it, and your RAG pipeline gets an instant veto from any experienced reviewer. This project is your unfair advantage because it speaks directly to every IT help desk and infrastructure team on the planet. Grab the Microsoft IT support dataset from Kaggle. It's free and contains real log messages and ticket descriptions. Use the All-Mini-LM L6 V2 model from Sentence Transformers to turn every description into a 384-dimension vector. Store them in files, then wrap everything in a Streamlit app that lets a user paste a new ticket and get the 5 closest historical matches. That single weekend of work proves you can bridge Gen AI with real IT operations. Put the repo link at the top of your resume and watch what happens. But here's the part. Almost everyone gets wrong about AI careers in 2026. 10 generic certificates don't land the interview. 1 solid RAG repo on GitHub does. The hiring market for vector database roles isn't scanning test scores. They're cloning your repository, reading your retrieval pipeline, and checking if you stored metadata on every chunk. Push that ticket triage project from earlier, put the live Streamlit link in your README, and link it on your resume above any cert. That's the proof of work that actually moves the needle. Interviewers for AI infrastructure roles don't ask fluffy questions. They drill into how you'd run a vector database under real load. When they ask about HNSW, you explain it's a navigable small world graph that gives sublinear search but consumes extra memory. It's the default in Weaviate and Milvus for a reason. For embedding model updates, you describe a versioned re-embedding pipeline and a blue-green deployment so you don't poison live queries. For retrieval quality, you don't just name recalc. You explain why a business proxy like resolved on first call matters more than a leaderboard score. And for scaling to 100 million vectors, you walk through product quantization, sharding, and swapping IVF for HNSW to keep P99 latency under 200 ms. Walk into the room with these answers and you'll be the candidate they can't stop talking about. KubeStellar, a major open source project, hit an 81% pull request acceptance rate. And it didn't come from better prompting. It came from a fleet of AI agents connected to a central vector store. The PR reviewer agent retrieves context from a high-dimensional embedding of the entire codebase before it even writes a comment. The issue tagger agent classifies bugs by comparing new issues to thousands of historical ones. A documentation agent drafts release notes by pulling semantically similar past announcements. When you show a hiring manager this architecture and explain why each agent is useless without the vector memory, you stop being a prompt tinkering experimenter and start being the person they trust with production infrastructure. Picture this. Monday morning, OpenAI announces a 5x price hike on GPT-4o tokens. Your competitor who built the entire product on prompt chaining just lost their margin before coffee. But your system? You built a vendor-agnostic RAG architecture. Your proprietary IT ticket data lives in a FAS index you control. Your chunking pipeline is yours, and your re-ranker runs locally. You swap the LLM endpoint to Claude or an open-source Llama model, retest the prompts, and you're back online by noon. That's the kind of infrastructure resilience that makes your salary recession-proof. And it's why senior roles demand vector database expertise, not just prompt fluency. This isn't a wish list. It's a timeline that maps directly to the career path of AI cloud engineers pulling north of $189,000. Start this week. Spin up a FAS index and embed a real dataset with sentence transformers. In 3 months, you have a live RAG project on GitHub solving IT ticket triage. That's your interview ticket. By month 6, you've layered hybrid search and cross-encoder re-ranking, and you can speak to retrieval metrics in an interview. At 12 months, you've containerized the stack on Kubernetes, implemented monitoring for drift, and you're walking into roles that companies can't fill fast enough. The 4 checkpoints aren't arbitrary. They're the exact milestones we see in successful career pivots. The market has already voted. Prompt-only roles peaked at just 7 of 359 nationwide postings, while AI engineering roles that specifically require vector database skills flood job boards. A prompt jockey earns around $164K but sits on a razor's edge. One model update and that custom prompt chain is junk. An AI architect who builds retrieval systems with face, Hudrant, and hybrid search commands up to $189K and owns infrastructure that gets more valuable as the company's data grows. This isn't about learning a new tool. It's about betting your career on the layer that actually compounds in value. Choose the right fight. If you want to see where the real money is flowing, look at this chart. Job postings mentioning RAG, vector database, or FAS, have exploded compared to prompt engineering, which remains a tiny fraction of the market, hovering around 7,000 postings. This isn't a fleeting hype cycle. It's the structural shift as every enterprise realizes that their proprietary data is the ultimate moat, and vector databases are the lock. The surfers who paddled out early are already landing senior roles. You're still early enough to catch the wave in 2026. Picture this. Friday at 5 p.m., your company launches a new feature, and 10,000 users flood the support chatbot. The LLM API rate limit kicks in, every new query returns a 429 error, and your shiny AI assistant is dead in the water. The team that had built a local vector index with face and pre-cached their documentation embeddings, they didn't even notice the spike. Their RAG pipeline served answers instantly without touching a single external endpoint. That's the difference between a fragile prompt wrapper and a resilient infrastructure engineer who knows vector databases. Most engineers don't realize that calling an embedding API for every user query adds up fast. Processing thousands of documents daily can cost hundreds of dollars a month just in embeddings, money that quietly drains your cloud budget. The smart move? Embed everything once, store it in a local face index, and only re-index when content actually changes. After the initial embedding cost, query time is practically free. That's the economic awareness that turns a junior developer into a senior architect who saves the company real money. Vector search today is powerful, but the next frontier is graph RAG. Combining embeddings with knowledge graphs like Neo4j to capture relationships that pure semantic search misses. Instead of just retrieving a document about Kubernetes, it pulls documents that discuss Kubernetes and Argo CD and how they relate to GitOps pipelines. That rich relational context crushes hallucination rates and puts you miles ahead. The best part? Your vector database skills transfer directly. By mastering FAS and Pinecone today, you're already standing on the doorstep of Graph RAG, ready to extend that career moat even further. In 2026, prompt engineer as a standalone role is a myth. Fewer than 8,000 jobs mention it, and even those expect you to also build retrieval pipelines. The professionals who design the memory layer that makes AI factual and reliable, they're commanding salaries between $170,000 and $189,500 a year. Mastering vector databases, embedding strategies, and retrieval systems isn't just a career upgrade. It's an unassailable professional moat. While AI commoditizes basic coding and prompting, The infrastructure you build becomes the competitive advantage every enterprise depends on. That's how you stay irreplaceable. Head to the link in the description to download the free Hired in IT Career Roadmap. It includes the exact sequence for building RAG skills, landing an AI infrastructure internship, and negotiating a top-tier offer. No fluff, no gatekeeping, just the concrete steps I showed you today. Go download it. Oh,